Hi everybody, it's Ms. Dupree. In today's lesson, we're going to talk about the rock cycle. You've already learned that there are three main types of rocks. The word igneous comes from the Latin root ignis, which means fire. Igneous rocks are formed when melted magma or lava cools and hardens into a new rock. Sedimentary rocks are formed when tiny pieces of rock called sediment squeeze together to form a new sedimentary rock. And the word metamorph means change. Metamorphic rocks are changed rocks. They form when a rock gets pushed deep underground where it gets exposed to heat and pressure. And this heat and pressure cooks the rock, turning it into a new and different rock. But once rocks are formed, they don't stay the same. Rocks change. So through different earth processes, rocks can be changed from one form to another form. And the process that changes rocks is called the rock cycle. The rock cycle is usually shown in a diagram like this one. And that's nice because really all you have to do is read the arrows. The arrows describe what's happening and they show you how the rock is changing. So we're going to go through this diagram one step at a time. So first, the rock cycle is a combination of materials and processes. So we'll start with the two materials that are needed to form rocks. Rocks can be formed from magma, which is our hot melted rock, which is going to cool and harden to form a new rock. And rocks can also be formed from sediment, which is those tiny pieces of rock that can get cemented together to form a new rock. So any rock is either going to be formed from magma or it's going to be formed from sediment. Okay, now let's take a look at the processes that can change one rock into another rock. Let's start with melting and cooling. Sometimes rocks can get pushed really, really deep underground by the movement of tectonic plates. And if they go deep enough underground, they're going to melt into magma. And then if that magma comes back up to the surface of Earth, it's going to cool and harden and make a new rock. And this can happen to any rock that gets pushed deep enough underground. So for example, here we have an igneous rock that was formed from melting and cooling magma. But if that igneous rock that's already formed, if it gets pushed back deep underground, it's going to remelt, turn back into magma, and then if that magma comes up to the surface, it's going to recool and it's going to make a new igneous rock. And this igneous rock has changed into just another igneous rock. So if a sedimentary rock gets pushed underground, it's also going to get melted into magma, and then that magma is going to cool and it's going to form a new igneous rock. And if a metamorphic rock gets pushed deep underground, the same exact thing happens. The metamorphic rock is going to melt, and then that magma is going to cool and harden and form a new igneous rock. So we've basically got this going, doesn't matter what type of rock it is, if that rock melts and then the magma cools, you're going to have an igneous rock. The second process that can change rocks is weathering and erosion. Weathering is the process where water or wind or ice can break down a larger rock into the tiny pieces of sediment, which we have here. And then the process of erosion is what happens when water or wind or ice move that sediment somewhere else. So you end up with all of these tiny pieces of sediment from lots of different rocks, and they just kind of all get mixed together. And then if the sediment gets squeezed together really, really tightly, and that's called compacting, and then those pieces get stuck or kind of glued together in a process called cementation. So at the end of compacting and cementation, you have a new sedimentary rock. So this process can happen to any type of rock. Here we have an igneous rock that gets broken down by weathering and erosion into sediment, and then these pieces of sediment are going to compact and cement, and now that igneous rock has turned into a new sedimentary rock. The same thing can happen to our sedimentary rock. It can get broken right back down again by weathering and erosion, and then it's going to compact and cement into a second new sedimentary rock. And yes, this can happen to a metamorphic rock also. If a metamorphic rock gets broken down by weathering and erosion into sediment, and that sediment compacts and cements, then that metamorphic rock has now turned into a sedimentary rock. Okay, the last process is heat and pressure. Sometimes rocks get pushed underground, but they don't go deep enough to melt. Instead, while they're underground, there's this tremendous amount of heat and pressure. And there's not enough heat to actually melt the rock, but there's enough heat to make it just a little bit soft. And then that pressure underground squeezes it really, really hard. And that kind of acts like an oven. It kind of cooks the rock and causes it to change. And so our metamorphic rock is going to be different after it cooks underground with that heat and pressure. And again, this can happen to any type of rock. If an igneous rock gets pushed underground, not deep enough to melt it, the heat and pressure are going to cook it and form a metamorphic rock. And in class, we saw the example of granite, which is an igneous rock, changing into gneiss, which is a metamorphic rock. If a sedimentary rock gets pushed underground, it can also get cooked by heat and pressure, and that's going to turn it into a metamorphic rock. In class, we saw the example of shale, which is a sedimentary rock, changing into slate, which is a metamorphic rock. And finally, a metamorphic rock can get pushed right back underground and keep on cooking from heat and pressure, which is going to change it into a different type of metamorphic rock. So an example is slate, which is a metamorphic rock. If it goes back underground and gets put under more heat and pressure, it can turn into a different type of metamorphic rock that's called schist. Okay, that's it for the rock cycle. You should understand that the rock cycle shows how rocks can change into other types of rocks. You should be able to read and interpret the rock cycle diagram, including knowing the materials needed to make rocks and the different processes that can change rocks. You need to make sure that you have this diagram very, very neatly drawn in your notebook with all of the color-coded arrows colored in, so that you can read and interpret this diagram. If you have any questions, please ask. Otherwise, you're all set. Good job, everybody. See you next time.